We are talking about transformations of quadratic functions, and we want to graph quadratic functions in standard form. So we're given an equation, j of x equals negative x squared plus 6x minus 8, and we want to compare it to the parent function. The first thing it says is find the line of symmetry, or the axis of symmetry. And the axis of symmetry, we know the equation is equal to negative over 2a. So it's negative b over 2a. So the negative and the 2 are always there, and then we get our b and our a from our equation. So here we know our a value is equal to negative 1, our b value is equal to 6, and the c value is equal to negative 8. So we can substitute those values into our equation. We want to make sure that we keep the negative and we keep the 2. So then we get 6 and negative 1. So that becomes negative 6 over negative 2, which is equal to 3. So our line of symmetry happens at x equals 3, or axis of symmetry. So on my graph, I'm going to graph the axis of symmetry. And that's at x equals 3. Now we want to decide, are we going to have a maximum or minimum value? And because our a value is negative, so a is equal to negative 1, because it's negative, that means that the graph is going to open down. So we should be looking for a max. And the way that we find that is we take our x value from our line of symmetry and we substitute it back into the equation. So we want to find j of x is equal to negative x squared plus 6x minus 8. And in this case, our x value we get from our line of symmetry, which is going to be 3. So 3 squared is 9, and then we have the minus, so that's minus 9, plus 18, minus 8. And so we end up with the function j3 is equal to 1. So our vertex, and that's where our max value happens, our vertex ends up being 3, 1. So I can go over 3, up 1, and that's the vertex. So we have the vertex, we have the axis of symmetry, and now we can think about what the y-intercept is. And the y-intercept comes from our c value, and that is just our c value. So 0, negative 8. So we actually can't graph it on this because we only make it down to negative 5, so we'll be down here for where we would graph our y-intercept. Now we still have to be able to graph based off of what we have so far. So from the parent function, if we were to graph the parent function, we have 0, 0, and then from the vertex we go over 1, up 1, over 2, up 4. That would be what the parent function does. So over 1 up 1, over 2, up 4, over 3, up 9. Now the A value is going to change what happens. We still want to go over 1, over 2, up over 3, but the A value changes what happens to the Y value. So we multiply by the A value, which in this case is -1. So instead of going up 1, then we're going to go down 1. Instead of going up 4, if we multiply by -1, that tells us to go down 4. Instead of going up 9, we multiply by -1, that tells us to go down 9. And this is from our vertex. So if I go over 1, then I need to go down 1. Over 1, down 1. Over 2, down 4. 1, 2, 3, 4. Over 2, down 4. So we have 3 points. Then we can find 2 more points by simply using our axis of symmetry. So this point is 1 over from our axis of symmetry. Now we go back 1 from our axis of symmetry. Go to the right 2 from our axis of symmetry. Now we go back 2 from the axis of symmetry. And then we can sketch our parabola from there. Two more pieces of information are the domain and the range. The domain is our x values. So in this case, this arrow has 2 components. It has an x component and a y component. For our domain, this portion of the arrow says it goes to -infinity. And this portion says it goes to +infinity. So our domain is all the values between -infinity and +infinity. Our range is the y values. And this arrow says that it goes to -infinity. And this arrow also says that it goes to -infinity. So we always start with the smallest value, and the smallest value is -infinity. We can't get any smaller than that. And then we're going to go up to the highest value. And in this case, the y value, the highest value is 1. The 1 is included, so we use a bracket. We can never count to infinity, so we use a parentheses because that is never included. Anytime we use infinity, will never be included. In this case, the 1 is included because that is the highest that it can be. Now, the last thing we got to look at are decreasing. And over here, our graph is increasing. It's increasing because we read it just like we read a paper or a sentence from left to right. So as we go from left to right and we trace the graph, we see that it increases all the way until we get to 3. So it starts at -infinity all the way to 3, and that's increasing. We don't include the -infinity because we never do, and we don't include 3 because the slope at 3 is actually 0. It's neither increasing nor decreasing, so we don't include it, so we use parentheses. Then we look at when is the graph decreasing. Well, after the vertex, then the graph starts to go down, and that is decreasing. And it decreases from 1 all the way to +infinity.